Okay guys, so today is going to be lesson 9.6, adding and subtracting rational expressions. Today we're actually going to begin with adding and subtracting rational expressions, but we are going to start off with somewhat of easy problems, and tomorrow we're going to go ahead and continue with slightly more difficult problems, just so you guys can get the idea of what it is that you guys have to do today, and how we're going to implement it into tomorrow's problems. Now, I went ahead and I provided you this right here, okay, so that you guys can see what's going on. So this one's a little bit different from multiplication and division because all you would do is just multiply them across, right? But now here, you're going to be adding and subtracting. Now, when you're adding and subtracting, though, number one, the golden rule for adding and subtracting fractions is that in order for you to be able to add or subtract fractions, the denominator has to be the same. Has to be the same. To be the same. Okay. If it is not the same, then you cannot be adding nor subtracting these fractions. Okay. So that right there is going to be the tricky part when it comes to this. Okay. That we need to make sure the denominators are the same in order for us to be able to do all of this right here. Okay. So with that being said, I give you the following steps right here. So the way that this works is it's called the least common denominator, the LCD. So that's what I'm going to be referencing. It adds through this, the least common denominator. So the first step to do is to find the least common denominator and then multiply the least common denominator to the numerator and the denominator of the other fraction. Now, that may sound a little bit confusing and what does this all mean? But I promise you it is actually pretty easy to see in the example visually, right? So let's look at this problem. If I look at it, I notice that I have 3y divided by 2x, and then I have plus, okay, 2z divided by 5x, okay? Now, in order for me to be able to to add these, I need to have the same denominator. Now, if I look at this here, I have a 2 and a 5, meaning that they're not the same value, so therefore I cannot add them. Okay, so if you notice, they both have an x, so that means that I do not need to add an x to make them common, right? So what I'm going to do, the least common denominator on the 3y divided by 2x is 2. And the least common denominator on the right side is the 5. So I am going to go ahead and multiply the first fraction by a 5. Okay, and what I do to the bottom, I do to the top. Okay, and now the second fraction is going to be multiplied by 2. And I'm going to put that in the bottom and the top. Okay, now by doing this is going to give me the same denominator on both sides. Because what I'm going to do is I'm going to multiply these across like this for both of them. So now I'm going to get 5 times 3 is 15y over 5 times 2, which is 10x. Okay, and I'm going to do the same thing to the second fraction. 2z times 2 is going to be 4z divided by 5x times 2, which is going to be 10x. Okay, so by doing that, I now have the same denominator of 10x plus 10x, meaning that now I can go ahead and add my numerators. Now, do keep in mind that when you add fractions, the denominator stays the same the whole time. It's not going to change. So I'm not going to have 100x squared because I'm not going to multiply these. It's literally just going to be 10x. So I'm going to end up with 10x in my denominator because that's not going to change. And now I have to add my numerators right here. So that's 15y plus 4z. Notice that they have different variables, so they cannot be combined together, but I can put them together with a plus sign in between them. And so that right there is my final answer. So the whole point of step number 2 right here, okay, the whole point of this step is to multiply the numerator and the denominator by the other fraction, so that way you can, at the end of the day, get the same denominator and therefore be able to combine them. Okay, so that's going to be the tricky part with adding and subtracting these rational functions. Okay, so now let's move on to example number 2. Okay, this one's going to be a little bit different because you have these trinomials right here. And so obviously seeing what they have in common and what they don't have in common is a little bit complicated when you don't see them in factored form. So the first step here would be to convert these to factored form. Okay, once you have them in factored form, it's going to be a lot easier for you to see what they do have in common and what they don't have in common. Okay, so let's go ahead and do that. Well, the numerator of the 4 is going to stay the same. 3, I'm going to go ahead and multiply 3 times 1, right? Because 3 times 1 is 3. But then they need to add to a negative 4, so I'm going to do negative 3 and negative 1. Okay, and those right there should be my factors for that. I'm basically just doing this in my head, but if you guys want to factor these, it'll be the reverse tabular method, where we did the little table here and we placed the numbers on the inside, or you guys can also just do tic-tac-toe. Okay, so that's the first fraction, and now the second fraction, I'm going to have x divided by x squared plus 5x minus 6. So we're going to go ahead and we are going to use 6 times 1, because 6 times 1 is 6. But I do need it to equal to a positive 5, so that means that I am going to make the 6 positive, and the 1 is going to be negative, because 6 minus 1 is going to equal to positive 5. So now if we look at this, okay, what do they have in common? The x minus 1 and the x minus 1. So what is different? What is different is going to be this x minus 3 and x plus 6. So since one fraction doesn't have the other, you cannot add them because they have something missing. So I'm going to go ahead and I'm going to write this just because my space here is limited. So we're going to get 4 over x minus 3, x minus 1, plus x over x plus 6, x minus 1. So the ones that were different were this one, the x minus 3. So that means that on the other side, I'm going to multiply times an x minus 3. But what I do to the bottom, I'm also going to do to the top. And now the other one that was different was this x plus 6, because the first fraction doesn't have an x plus 6. So that means that I'm going to multiply the other side times that x plus 6. But what I do to the bottom, I'm also going to do to the top. Okay? So if I rewrite this as a whole fraction, I'm going to have 4 times x plus 6 over x plus 6, x minus 3, times x minus 1, plus x divided by, x times x minus 3, over x plus 6, x minus 3, and x minus 1. Now, if you look at this, okay, they both now have the same denominator, meaning that now that they have the same denominator, I can go ahead and add my numerators. And remember, the denominator is not going to change. The denominator will stay the same. Okay, so what I'm going to do here, I'm going to go ahead and I am going to distribute this 4 in here and in here, the x in here and in here. Okay, so if I do that, I'm going to get 4 times x, which is going to be 4x, plus 4 times 6, which is going to be 24. Okay, and then I'm going to have plus, okay, I'm going to put this in parentheses here and then put the other one in parentheses, x times x, which is going to be x squared, and then x times negative 3, which is going to be negative 3x. And now I'm going to put all of this on the same fraction because they both have the same denominator. X plus 6, x minus 3, x minus 1. Okay, so here I have a plus sign. So this plus sign isn't really going to change much. So that means that these parentheses can drop down because you're literally just going to distribute the positive, but a positive times anything is just going to remain the same. So you're going to have 4x plus 24 plus x squared minus 3x divided by x plus 6, x minus 3 times x minus 1. Combine like terms. In the numerator, well, what can I combine? I can combine the 4x minus 3x. 4 minus 3 is going to be 1. So my final answer here is going to be x squared plus x plus 24 divided by x plus 6, x minus 3 times x minus 1. Now, do I have to FOIL the denominator here? No, guys, not really. You can, but it's unnecessary. If you guys would have taken the test, I think your answers would have looked something like this anyways. So that right there is your answer. So now we're going to go ahead and move on to the third example right here, which is still going to be the same thing. We need to make sure that our denominators are the same. So we are going to factor these out. Now here in this denominator, 6x minus 18, I notice that it is a subtraction, so it could be different squares, but the only problem is that it doesn't have a power of 2, or they can't be square rooted. So we're going to go ahead and we're going to do greatest common factor for this one, because I do see that the 6 and the 8 are divisible by one common factor. And then over here, I can also see that this one also has a common factor. So I'm going to go ahead and do greatest common factor here first. And then once I do the greatest common factor, I am going to factor using reverse tabular, or you can use tic-tac-toe as well. Okay. So 6x minus 18, they have a greatest common factor of 6. Right? Because 6 is divisible by 6 and 18 is divisible by 6. So remember, whatever you take out, you put outside in parentheses. So 6 divided by 6 is just going to be 1x. And then 18 divided by 6, well, that's going to be 3. So you're going to end up with 6x minus 3. So my first fraction is now going to be 5 divided by 6 parentheses x minus 3. Minus the second fraction. Well, can I do anything to that x minus 1? Not really, so it's just going to stay as an x minus 1. Okay, but now over here for this 4x squared minus 14x plus 6, they all have a common factor. 4, 14, and 6 are all divisible by, by 2. Okay, whatever you take out goes on the outside. So 2. 4 divided by 2 is going to be 2x squared. Negative 14 divided by 2 is negative 7x. And then 6 divided by 2 is 3. So that right there is going to be my new denominator. So I'm going to go ahead and put 2 parentheses 2x squared minus 7x plus 3. Now the thing here is that I still don't see what they have in common, because I still need to simplify this denominator right here even further. So we're going to go ahead and we're going to do tabular method to go ahead and break that down. Okay. So I'm going to have 2x squared, 3. Okay. And I have to figure out, well, what multiplies to a positive 3 but adds to a negative 7x. Okay, do keep in mind that one of these numbers is going to get multiplied by 2 because you have a 2x here, because 2x times x is going to be 2x squared. So we can go ahead and literally think of just 3 and 1. I'm going to write it twice because I can go ahead and multiply the 3 by 2 or the 1 by 2. 2 times 3 is going to be 6 and then 1. And then 3 is just going to be 3 and 2 times 1 is going to be 2. Okay. Now, I need this to equal to a positive 3, but they need to add to a negative 7. So that means that this needs to be negative, this negative, negative, and negative. So that means it'll be a negative 6 minus 1, which is a negative 7. A negative 3 minus 2 is a negative 5. Do I like this one in the bottom? No. So I'm going to go with this top one right here. Okay, so that means that I'm going to get a negative 3x and a negative 1x. Okay, so x times what is negative 1x? Negative 1. 2x times what is, my bad, messed up. Negative 6x. 2x times what is negative 6x? Well, that's going to be a negative 3. Okay, so my factor here is going to be 2x minus 1 times x minus 3. So I'm going to go ahead and rewrite my fraction again to replace that. So I'm going to get 5 divided by 6 times x minus 3 minus x minus 1 divided by 2, parentheses, 2x minus 1, x minus 3. Okay, because this 2 right here does not disappear. It's still there. Okay, so if I notice here, what do they have in common? The x minus 3 and the x minus 3. So that means that the first fraction needs to be multiplied by a 2x minus 1 because it does not have a 2x minus 1. So I'm going to go ahead and I'm going to multiply this first fraction by 2x minus 1. And what I do to the bottom, I'm going to do to the top. Okay? And so now that's going to be the same. This is going to be the same. This is going to be the same. And this is going to be the same. The only thing that we're missing now is going to be this 6 right here. Now, I do have a 2 here, but it's not a 6. So what can I do to that 2 to make it a 6? Well, multiply it by 3. Excuse my nephew, guys. He tends to not understand what do not disturb means. But we're going to go ahead and we're going to multiply by 3 on the other side, because I need to make sure that 2 times 3 gives me this 6 right here. So if I do that, then that should be the same. Okay, and what I do to the bottom, I do to the top. So now we're going to go ahead and multiply by the missing factors. So that means that 5 times 2x and then 5 times 1. Well, 5 times 2x is going to be 10x. 5 times negative 1 is going to be negative 5. Okay, minus this one on the other side, which is going to be a 3 times x and a 3 times negative 1. Well, 3 times x is going to be 3x, and then 3 times negative 1 is going to be negative 3. Okay, those right there are my numerators. So now I'm going to go ahead and combine everything with my denominator of 6 times x minus 3 times 2x minus 1. Because now my denominator is the same, the numerators can be combined together. Now notice here, I did put a subtraction because this right here was being subtracted. And negative signs do tend to affect the values of the whatever you're trying to multiply inside. So I put a subtraction here. Not only that, I also put parentheses. Okay, why? Because we have to distribute the negative here. Now, when you're distributing additions, it doesn't really change, but subtractions do change the value. So make sure to put parentheses, because if you don't, you're going to get the answer wrong. So that means that you're going to get 10x minus 5, a negative times a positive, negative 3x, a negative times a negative, a positive 3. All of this divided by 6 times x minus 3, 2x minus 1. So as soon as you figure out the denominator, guys, you literally don't have to worry about it ever again. Now let's combine the like terms in the numerator, and that would be 10x minus 3x. Well, what's 10 minus 3? 7. So, and then the other one, I forgot about this one. Negative 5 plus 3. Well, what's negative 5 plus 3? Negative 2. So we're going to get 7x minus 2 divided by 6 times x minus 3 times 2x minus 1. Okay, and that right there is your final answer. Okay, that is going to be the first part of the lesson. Tomorrow we're going to talk about the second part, which is similar problems to this, but with slight differences. Okay.